Okay, so in this video, we're going to talk about section 9.3. So you should have a new packet. I'm not sure what color that's going to be yet, but everybody make sure you've got that new packet and you're going to turn to that first page. Today, we're talking about starting to connect the quadratic equation to the graph of the parabola. So we know that a quadratic equation is going to make a parabola if we graph it, but we haven't talked about how to actually do that without the help of Desmos at this point. So that's what our big goal is today. First off, at the very first thing we're going to do here is just reviewing some information about quadratic functions, and mostly just what a, b, and c is. So as a reminder here, when we write our quadratic function, we've got ax squared plus bx plus c. A is the number in front of the x squared term. B is the number in front of the x term. There might not be one of those, so it could be 0. And c is a number that is all by itself. That one could also be 0 if there is no number all by itself. So here, if I look at my x squared term, I see just a negative sign. I have to remember that's really negative 1. I don't see an x term at all, so that means it's really just 0x. There are no x's. And then my c term is this 7, that number just by itself. On this second example here, we have to distribute first. So if I take 2x times x, right? 2 times the hidden 1 is 2. X times x is always x squared. And then I'm taking 2x times negative 4. 2 times negative 4 is negative 8. And then x times, well, there's nothing to multiply the x by, so it's still just x. It hasn't changed. So here, the number in front of my x squared term is 2. The number in front of my x term is negative 8. And there is no number by itself because we've distributed. There's no number by itself anymore. C is going to be 0. So that's kind of the way those two can look. Let's go ahead and start to look at the relationships between the equation and the graph. So on this example here, what we have is just 4 graphs, all slightly different. And we're going to look at the relationship between A, the A value, and the relationship of the graph, or the shape of the graph. So in our case, we have just gotten functions that don't have a b and don't have a c. It's just an x squared term, so we can really focus on that a. So here, the a is 1. You can see there, nothing written there, just 1. Here we've got a 2 in front. Here we've got a negative sign, which is really a negative 1. And here we've got a negative 3 in front. And when we compare these, you're going to see that the 1 and the 2 are both up graphs, where the negative 1 and the negative 3 are both down graphs. And so what happens here is if A is positive, the parabola goes up, which is really nice because positive up, that makes sense. If A is negative, then it goes down. Yeah, that makes sense, right? This is a pretty intuitive thing for most people. If A is positive, that very first number, the parabola is always going to go up. If that very first number is negative, then it always goes down. And the thing we're going to find here is it doesn't matter what B and C are at all. The A value itself is going to tell us whether the graph goes up or down. So the next thing we're going to look at is C, and C is kind of the next easiest one. If I look here, I see C is the number by itself. So here C is 1. Here C is 0 because there isn't a number by itself. And here C is negative 4. What I want you to do is look at the y-intercepts on these. Y-intercept, again, just like on our quiz yesterday, is where the graph crosses the y-axis. So there it's 0, 1. Here it's 0, 0. And here it's 0, negative 4. And I want you to make a little connection here. The C value is always the y-intercept. So C is the y-intercept of our graph. And the reason for that is when we plug in 0, the y-intercept, let me word that a little bit differently here. The y-intercept of our graph occurs when x is 0. And if I plug in 0 for x's, all the x terms are 0, the only thing left is c. So I'm going to write only thing left is c. That's why the y-intercept is 0. And if we want to make an even bigger connection here back to the very beginning of the year when we had our linear functions, this is not in your notes, but if we compare to our linear functions, we used a different letter here. We used b in this case, but that number by itself was our y-intercept because when we plugged in a 0 for x, that went away. Now that we've got our quadratic equations, when we plug in 0 for x, that goes away, c is what's left. Okay, so here we're going to do our first two examples here of just identifying a, b, and c, whether the graph goes up, up, or down, down, and the y-intercept. I'm going to do the first one together, and then I'll pause the video, or we'll pause the video, and you can do the next two on your own, and then we'll check them. So here, we've got our hidden 1 in front of the x squared, so ax squared, a is 1, bx, so b is that negative 2, and then c is the number by itself, positive 1. For the up, up, or down, down, I only look at my a value. A is 1, positive 1, means it goes up, up. My y-intercept is going to be our c value. X is always 0, y is our c value. So my y-intercept is going to be 0, 1. So pause the video, take 2 minutes or so, maybe a little bit less, try these out, and then we'll come back and talk about them. Okay, so in this video, or this one here, a is going to be negative 2, so it's negative 2x squared. B is going to be my number in front of my x. Well, there's no number in front of the x. That's a hidden 1, and it's a negative, so negative 1. And then there is no number by itself, so that's going to be 0. The negative 2 for a is going to tell me that it's a down, down equation. And then the c value is going to be my y-intercept. So something comma 0, in this case 0 comma 0, because it's a y-intercept. And the y-intercept, the x value is always 0. Then on example 3, we've got 1/2 x squared, so 1/2 is my a value. There is no x term. This is x squared, not x. So there is no just x term on its own, which means b is 0. And then my c value is the number by itself, which is that negative 10. Don't forget the negative sign. When I look at up, up, or down, down, a is a positive number, 1/2, so up, up. And my y-intercept is going to be 0, comma, negative 10, because the c value is negative 10. One thing I want to mention here, if at any of these points you're having some questions that you're not getting answered from the video, what I want you to do is write those questions down so that we can talk about them tomorrow. And if we write those questions down and I happen to talk about it later in the video, great. But one of the biggest things when I'm not able to be here is it's hard to ask questions, and maybe tomorrow you're not thinking about what questions you had. But right now, I just want you to think, if you have a question, write it down. Put a little star on it, write down what question you have, and we can talk about those tomorrow. Example 4 here, we're kind of combining some things that we knew already. We've done a few of these on the homework before. So we want to draw the parabola. We know the axis of symmetry equals the axis of symmetry is x equals 2. That is a vertical line at 2. So I'm going to just draw a dashed vertical line through 2. My vertex is 2, 3. One thing you'll really want to know here is that the axis of symmetry has the same x coordinate as the vertex every single time. I'll come back to that in a little bit here. It has a y-intercept at 0, 5. And it has a minimum point, which means my vertex is my minimum point, which means this graph is going to go up from here. I'm going to draw this side. To draw this side, I'm going to use the reflection of my point. So this point is 2 units away, 2 boxes away from the axis, 2 more boxes away. Gives me that point. And then how many x-intercepts does this have? None. It does not cross the x-axis. Remember, we talked about how parabolas can have 0 x-intercepts, 1 x-intercept if it just touches, or 2 x-intercepts if it crosses twice. Okay, Here we go. The last section is the hardest part of this thing, okay? It's going to be a lot of steps involved, but each time you do this, you're going to see the exact same steps. So this isn't something that's going to be a little bit different each time. This is something that's going to be exactly the same each time. So you can come back to these notes and keep looking at how to do this. So our first job here, we're going to try to graph this equation all by ourselves with no help from a graphing calculator, only by looking at that equation. First thing we're going to do is identify our a, b, and c. So a is going to be the number in front of the x squared. This is 1. B is the number in front of x. That's -4. And c is the number by itself. That's 7. We're going to keep identifying a, b, and c the rest of the year. Those are really important things. A is going to tell us whether it goes up, up, or down, down. Because it is a positive 1, it goes up, up. C is going to tell us the y-intercept is 0, 7. Okay, so that's what we knew already. Now this next section here says axis of symmetry, and it's got a little equation for us. This equation right now, we're just going to tell it to you. Later on, we will talk about where this comes from. For now, it's going to be a little bit of magic. That's okay. We will get there. I promise it's not going to stay magic forever. The axis of symmetry is always going to be x equals the opposite of b divided by 2 times a. So this is the place where b shows up. It tells us, where the axis of symmetry is, so how far left or right it is. So what we're going to do here, since we know a is 1 and b is -4, I'm going to plug those numbers in. Now here the key is, it's the opposite of b, negative b. So negative -4, because b is -4. And then 2 times a, 2 times a was 1. Just like any other point in the year, when you saw a negative, that is going to turn into a positive. I like to think of this as the opposite of b. So since b is -4, the opposite of b is +4. But you can also think of it as a negative, which is a positive. 2 times 1 is 2. And clearly they are wanting me to go down here, sorry. And then 4 divided by 2 is 2. So my axis of symmetry is x equals 2, which I know is a vertical line through 2. So I'll go ahead and draw that dashed line all the way through. I'm also going to take this opportunity to go ahead and graph my y-intercept, because I haven't done that yet. So 0, 7 is right there. And then I'm going to go ahead and count 2 over. So I know I've got those 2 points. I also know at this point that my parabola goes up, up. So it's going to look something like that. You can see me tracing on the screen. What we don't know is where the vertex is yet, and that's the last step. And we'll tell you, that's the hardest part for most people. Finding the axis of symmetry is pretty tricky, but then finding the vertex is the next big thing, okay? So we're going to go ahead and go down here. I'm going to copy this over so that you can see it. So right now our graph looks like this. X equals 2, y-intercept at 7, counted over 2 again. There we go. So in the gray box, gray boxes are always some of the most important things. It says, where is the vertex located? And we've talked about this a lot. It is on the axis of symmetry, on the AOS. What that means is that the x-coordinate of the vertex is the axis of symmetry. And so if we know the x-coordinate already, how do you find the y-coordinate of the vertex? You plug the x value into the equation. That's how you find a y value of anything at all. If you know the x value, you plug it into the equation, you simplify it, and that gives you the y value you want. We now have the way to find that x value. Since we know the axis of symmetry is x equals 2, that x value gets plugged in where the x's go in your equation. So this was the equation y equals x squared minus 4x plus 7. Now in place of the x, since I know x is 2, I'm putting in 2's. Eventually, I'll let you probably just use a calculator on this, but for now, let's go ahead and practice this. 2 squared means we're doing 2 times 2, that's 4. 4 times 2 is 8, so we've got a minus 8 and a plus 7. And so 4 minus 8 is negative 4. Negative 4 plus 7 is 3. So my y-coordinate is 3. And then I think, okay, well, y-coordinate is 3. What's the x-coordinate? Wait a minute, we already did that. We plugged in 2. 2 is the x-coordinate. So the coordinate 2, 3 is our vertex. One more time just to review this. The whole reason this works is because we know that the vertex is on the axis of symmetry. When we found the axis of symmetry using our formula, we got x equals 2. That 2 is the x-coordinate of our vertex. Once we know the x-coordinate of a point, we can plug it into our equation, and either using a calculator or by simplifying using our order of operations, we can figure out what the y-coordinate is. That finishes up our point, and we can graph it. That process right there of finding the axis of symmetry using the formula, taking that number and putting it into the equation to find the vertex, that's the big thing today. The A, most people have no problem with that, up, up, down, down. C is the y-intercept. That's okay for most people. This part's the hard part. So we'll talk about it tomorrow for sure. What we're going to do right now is finish up plotting our parabola. Now we know we've got our vertex there, our points there, and we'll go ahead and draw our parabola. We already knew it was up, up, but this kind of confirms it. Once we've got those 3 points, it's definitely going to look like this. And we've got our parabola. We can see there's no x-intercepts this time, which is fine. And we've graphed it. So we've got 2 examples here. We're going to do this next one here together. And then what I'm going to have you do is try number 2 on your own and see if you can figure that one out. We'll go over it at the end, but we're going to try it on your own for real. Give it your best shot. So number 1, A, B, and C. 1, hidden 1 there. 2 for B, 1 for C. To find my axis of symmetry, it is negative B, so negative 2 over 2A. A is 1. And I'm going to simplify this. Negative 2 is just negative 2. 2 times 1 is 2. And negative 2 divided by 2. Well, 2 divided by 2 is 1. One of them is negative, so it's negative. X equals negative 1. That is our axis of symmetry. What that also is the x-coordinate of the vertex. The x-coordinate of the vertex is negative 1. So to find the y-coordinate, I'm going to take this negative 1 and plug it in everywhere I saw an x in the original equation. Negative 1, negative 1. I'm going to simplify this by hand. We have access to a graphing calculator or a scientific calculator. If you're using a calculator, those parentheses are important. So negative 1 squared means I'm taking negative 1 times negative 1, which is a positive 1 because a negative times a negative is a positive. 2 times negative 1 is negative 2 and plus 1. And when we add those together, 1 minus 2 is negative 1 plus 1 is 0. And so I have the coordinate. The negative 1 is my x-coordinate. 0 is my y-coordinate. That is my vertex. Now, on this graph, on this problem, they did not ask you to graph it, but we're going to go ahead and do it right now, even though there's no place for it on your paper. I'm going to start by plotting my axis of symmetry. X equals negative 1. So I'll go over to negative 1 and graph it. My vertex is at negative 1, 0 right there. The other things I'm going to have to look at are, what is C? Well, C is 1. That means that my y-intercept is at 0, 1, right about there. I can flip it over. Since it's 1 unit away, I can go 1 unit away and plot a point over there. And since my A value is positive, I know I've got an up, up parabola, which I could already kind of tell just by looking at where my points were. It looks like that. So it didn't ask you to do that, but we're going to keep working on that. That's the big thing for today. Last one. Pause the video. 5 minutes. Really, really try this out. Look back at the examples. you might need to go back and figure out, well, what's A, B, and C? Find one that looks kind of like that. Look over to the side of your paper for this axis of symmetry equation, some examples of that. When you find your axis of symmetry, plug it back in and see if you can figure out what the vertex is. So pause the video. We'll come back and talk about it. Okay, here we go. Last one. I really, really, really hope you tried this. You do not get any better until you actually try to do something. Okay, so A is the number in front of my x squared, which is 1x squared. B is my number in front of the x, -6. C is the number by itself. There isn't one, it's 0. When I go to find my axis of symmetry, my equation is x equals -b over 2a. So I've got negative there already, but my b is a -6, so it's -6. My a is a 1, plug that in there. Important thing to see here, -6 makes a +6. Minus a negative is a positive number. 2 times 1 is 2. And when we simplify our fraction, 6 divided by 2 is 3. My axis of symmetry, x equals 3. From there, a key connection to make here, if the axis of symmetry is x equals 3, the x coordinate of the vertex is 3. Because the axis of symmetry, the vertex is on the axis of symmetry. From there, I can take my x coordinate and plug it into my equation where the x's are and simplify. 3 squared, 3 times 3 is 9. Minus 6 times 3. 6 times 3 is 18, so minus 18. And then 9 minus 18 is -9. So my vertex has an x coordinate of 3, a y coordinate of -9, and that's my vertex. At this point, again, there's no spot to graph this, but you will be doing this in your homework. I have the axis of symmetry at x equals 3, so I'll just kind of go over 3 and draw a dashed line. The vertex is down at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, -9 to be there. If I look at my equation, c was 0, so my y-intercept is actually at 0, 0. And I can plot another point by saying, okay, well, 1, 2, 3, 1, 2, 3. That's my other point. And draw the graph. And then make a little double check. This is an up graph. Well, A was positive, so yeah, that matches. It definitely should have been up. So at this point, your worksheet, your proficiency practice is a big chart. The first page has all the fill in the blanks for you. You're going to just take your A, B, and C and plug them in the same way we've been doing. And at the very end, you're going to graph it. The second page, the back of that page, is the same exact chart, different equations, but they've taken away all the fill in the blanks. They're the same questions. You're going to do the same thing, but the fill in the blanks are gone. Try to do as much of it you can without looking back. Everybody needs to be able to do that fill in the blank stuff. That's what I'm looking for, to see that you've got at least enough to move on from Algebra 1. I would like to see as many of you as possible that could do it without that extra help. Tomorrow we will come back together, maybe do another example, or maybe do one of the homework questions, and you will have some time to work on the practice. If you wanted to do a retake on the test, we could do that, but you have to be doing this practice still. We can't have a retake on the test if you're not doing the practice for the next one. So I will see you all tomorrow.